Problem number 1. What we want to do here is solve this equation, x minus 9 equals 4, where x is some real number. So we're looking for this. What number would we use here to subtract 9 and get 4? So before we just jump in and solve this equation, let's take a look at the big picture here to see what it is that we're actually doing as we go through the solution process. Right here I've drawn the way I kind of think of things is that we have these computing instructions, and in this case, here's our computing instructions. Take a number, subtract 9. So those computing instructions, that's what goes in this middle box. That's our instructions. It's like a recipe. It says, take some number, subtract 9. And what we want to know is, what is this number here to get this number out here? This is going to produce this number here. So what number x, let's put x as our inputs, what number here would we insert here, compute with, and get a 4 back out? That's what it means to solve an equation. So let's think about what it is that we actually did here. What we did is we took one of these numbers, we put it in here, right? We took that number, replaced the x with that number, and then we subtracted 9 and we got 4. So imagine doing this, right? I mean, this is just something in order. You take a number, subtract 9, you get 4. So what we want to do is we want to back out and see what that number was. So if you take that number and then reduce it by 9, you get 4. So why don't we do this? Let's take what we have here. This number here is a 4, and we got that by subtracting 9. Why don't we back it out and add 9? So what we're going to do here is we're going to take our x minus 9, which is currently equal to 4, and we're going to back this out. So what I'm going to do is I subtracted 9, so I'm going to back that out by adding 9. But I have to add 9 to both sides to keep this thing balanced. And now I've got this, x, and then subtract 9, add 9, we're just adding 0. This is 13 over here. X plus 0 is x, so there we go. X is equal to 13. Now, we don't have to show all this every time we solve an equation, but that's what we're doing here. This is just to illustrate the process. I'm going to take a number, put it in, compute, I get a number back out. So to go backwards, I'm going to undo what I just did. What I did was subtract 9, undo the subtraction with an addition. Here in problem 2, we're going to take some number, we're calling it t, it's unknown to us right now, but we're going to take that number and subtract 17, and that's going to give us negative 18. So what we did is we took some number, subtracted 17, that took us over here, so why don't we undo the subtraction with its opposite operation, which would be an addition. So what we're going to do here is we're going to take that t minus 17, we're going to add 17, that'll give us negative 18, and then add 17 to that side. Right here we've got a 0, so it's t plus 0 equals negative 18 plus 17 is negative 1. And t plus 0 is just t, so t is equal to negative 1. There's our solution. Now, oftentimes we'll just skip this step because we know that's why we're doing it. We know we're going to get 0. 0 added to any number is just that number. So if you like, you can skip this step. Problem number 3, we take some number and we add 5, and that brings us to 27. So to start with that number, we added 5. Let's undo the addition with a subtraction. So we'll take our x plus 5 and then we'll subtract the x plus 5. But we have to do that to both sides. So this will give us x equals, right, I'm not going to write the 0. 5 minus 5 we know is 0. 0 plus x is just x. And then I've got 27 minus 5, which is a 22. Now, you might want to run a check. If you put that 22 back in here, 22 plus 5, sure enough, is 27. And we have this equation solved. Here in problem number 4, we're going to take some number, we're calling it y, we're going to add 30 to that number, and we're going to get 22. So we're taking a number and we're adding 30 to it. So let's undo that addition with a subtraction. So how about if we take our y plus 30, subtract the 30 to undo the addition, then we'll have 22 minus 30. So on the left side, we'll get y equals, right, the 30 minus 30 is 0, equals, and over here, 22 minus 30 is a negative 8. and that equation is solved. Here in problem number 5, we're taking our unknown number, we're adding a fraction, we're adding 1/6 to this number, and we're getting negative 2/3. So we know what we do here. We're adding 1/6, so let's undo the addition with a subtraction. So we'll start with our x plus 1/6, and we'll subtract 1/6, but we have to do that to both sides. Now on the left side, we'll get a 0 here, so we'll get x equals, and now over here, we're adding two fractions, and to add two fractions, we need a common denominator here. Now the common denominator here, I think we should use 6, because 6 is the smallest number both 3 goes into and 6 goes into, right? 6 goes into 6 once, 3 goes into 6 twice. So the LCD here is 6. So I'm going to make everything sixth. This is already a sixth. Now, to do this, what I'm doing here is multiplying this denominator by 2. So I have to multiply the numerator by 2. 2 times 3 is the 6. 2 times negative 2 is negative 4. Now I'm adding two numbers with a common denominator, so I can just write that common denominator and combine the numerators. Negative 4 minus 1, that gives us negative 5 over 6. And this equation is solved. Now let's look at number 6. What we're doing is we're taking our number and adding 4, or actually we're taking 4 and adding our number. And that brings us to negative 7. So we've got our number, but we've added that to 4. Why don't we subtract the 4, right? That's the opposite of addition. So let's eliminate that 4 by subtracting it. 4 plus, we'll take subtraction here. So how about if we do this? 4 plus x, we'll subtract 4 from both sides. Now, this 4 minus 4 is 0, so that'll just give us x equals negative 11. And here in number 7, this is a little bit different because the variable is now on the right side instead of the left side like it has been before, but it really doesn't matter. We're taking our unknown and we're adding 13, so let's undo the addition with a subtraction. So I'm going to subtract 13. Make sense? We added 13, so we'll subtract 13. So, you know what I'm going to do this time here? What I'm going to do is I'm just going to tell you what I'm going to do. I'm going to subtract that 13. So now I'm going to actually do it. So I'll get 8 minus 13 equals t plus 13 minus 13. On this side here, the left side, the 8 minus 13, that's a negative 5. This is equal to t, and then over here, 13 minus 13 is 0. So we get negative 5 is t, okay? Now negative 5 is t, you know, that's just the same. Negative 5 is t. That's the same as saying t equals negative 5. Problem number 8. We've seen one like this before when we did number 5. So in number 8, what we're doing is we're taking negative 3/4 and we're adding our unknown number. So it doesn't matter if we take negative 3/4, add our number, or take our number and then add negative 3/4. What we've got here is we're adding negative 3/4, so I'm going to subtract negative 3/4. Or if I subtract a negative, what I'm doing is actually adding. So this is going to look like this. Negative 3/4, I'm going to add 3/4. So 3/4 minus 3/4 plus y equals negative 2/3 and then plus 3/4. So over here, we've got a 0, so we'll just have y equals now. What about this side? We need a common denominator here. So what is the smallest number that maybe 3 and 4 divide into? Doesn't have to be the smallest. It just can be any number that 3 and 4 divide into. I can see 12. Both of them go into 12, and that happens to be the smallest. So I'm going to make these denominators into 12s. Make them 12s. And to do so, to get a 3 to a 12, we multiply it by 4. So I have to multiply the top by 4. So negative 2 times 4, negative 8. And then over here, to get the 4 into a 12, we multiplied it by 3. So I'll have to multiply the top by 3. 3 times 3 is a 9. Here's two fractions with the same denominator, so I'm going to write that denominator and combine the tops. Negative 8 plus 9, that's just a 1. So y is equal to 1/12. And that equation is solved. Now, number 9, this is a little bit different than we've seen before because now I have my unknown on both sides. I've got x on the left side and the right side. So the object here is to get all the x's on one side and the constant on the other side. So because I have x's on both sides, I'm going to choose a side on which to get them. So do I want them on the left side or do I want them on the right side? Well, when I do these, I typically like to choose the side on which I have more x's already. Over here on the left side, you can see we have 8 of these x's. This is times, and times mean of. I have 8 times x, 8 of these x's. So I got 8 x's over here. On the right side, I have 7 of those x's. So I have only 7 over here. We have more x's on the left side. Let's get rid of these. So we have positive 7x. So the plan, I think, is to, I'll say what I'm going to do here. I'm going to subtract that 7x. Here's what it's going to look like. I have to do it to both sides. So it'll be 8x minus 7x equals 7x plus 5, and then minus 7x. Now over here, 8x's minus 7x's, that's just 1x. You can write the 1 if you like. You don't need to. Equals, now, 7x minus 7x, no more x's, and we're just left with this 5. So x is 5, and I've got the equation solved. And here in number 10, we've got x's on both sides, so I'm going to choose a side. Now, typically, I like to choose the side on which I have more x's already, and that's what I'm going to do. But I'm going to do this one two ways. I have more x's on the left side than I do on the right, so I'm going to get rid of these. Now, I have positive 8x over here, so what my plan is to get rid of those. I'm going to subtract that 8x. It will look like this. We'll have 9x plus 1, now subtract the 8x, equals 8x minus 8x. Over here, 9x's minus 8x's is just 1x, and then we have the plus 1, equals 8x plus minus 8x is 0. And now I can solve this equation just by doing what? Right here, I've got my variable plus 1. Undo the addition with the subtraction. So the plan is to subtract 1. It will look like this if we do that. X plus 1, subtract the 1, equals 0 minus 1. We got a 0 right here, so we'll get x equals, and 0 minus negative 1 is negative 1. There's one way to solve this. Now, here's another way. You know what I'm going to do here is I'm going to rewrite this thing. Just another way to do it. 9x plus 1 equals 8x. What if I got all the x's on the right side? So if I get these x's on the right side, here's what would happen. I got 9x's over here. Let's get rid of the 9x's. I'll subtract them, right? Positive 9x. Let's subtract 9x. So it would look like 9x plus 1 minus 9x equals 8x minus 9x. 9x minus 9x is 0, so I just get 1 equals, now 8 of those minus 9 of those is just negative 1 of those. Now here's something we haven't actually gotten to yet. I've got a multiplier on the x now. Every other time we did that, we just had a 1x, a 1y, a 1t, a 1x, but now I've got a multiplier. So I'm multiplying, so this will kind of take us into the next section. How do you undo a multiplication? You undo it with a division. So what I'm going to do here, and we'll talk about this more in the next section, is I'm going to divide by negative 1. Write that negative 1 right there. So if I divide by negative 1, we'll get 1 divided by negative 1 equals negative 1x over negative 1. Negative 1 over negative 1 is negative 1 equals negative 1 divided by negative 1 is just 1x. So you can see what we've got now. Up here I got x equals negative 1. Down here I'm getting negative 1 equals x. Same thing, x is negative 1 is x. So either way you do this, you get the same answer.